Flippin' Physics.
Good morning, everybody. Welcome. This is my Unit 1 AP Physics 1 live Kahoot multiple choice review. I'm hoping I have people here. Hoping people can hear me. Yeah. Maybe give me some comments just to make sure people are here. Oh, good. Okay, that's good. Sorry, it's hard to assess what's going on. All right, so you can clearly hear me, I hope, and I see you guys are starting to log in for the Kahoot. That's awesome. All right, so here we go. So, welcome. Please sign up for the Kahoot. Clearly, you're already doing that. Just so you know, Unit 2 will most likely be on Tuesday, October 21st at 7 p.m. Eastern Time. That's my plan right now. Yes, I am planning to do one of these every third Tuesday of every month. So, Section 1 of the AP Physics exams have 40 multiple choice questions in 80 minutes. That means you get 2 minutes per multiple choice question. So today on the Kahoot, for every question, you're going to get 2 minutes, just so you know. So just like the AP exam itself, you are going to get 2 minutes on each of these questions. So I just take a moment to say hello to our moderator, Miss Bonk. She is in the chat to help you guys out. She is an AP Physics and I'm Project Lead the Way teacher at Addison Trail, Wisconsin, which is a suburb of Chicago, just like Ann Arbor, where I live, is a suburb of Detroit. I believe it's pretty far from Chicago, pretty far west of Chicago, but still technically like a suburb of Chicago. So while we're here, I will talk for a moment about the Ultimate Exam Slayer. So be aware that the 10 multiple choice questions we're going to go through today are in the using the testing software in the Ultimate Exam Slayer, and actually are the first 10 questions in a multiple choice quiz in the Ultimate Exam Slayer. So if you do get that, you'll get the other 16 questions that are a part of this multiple choice quiz, but you get the first 10 for free here on YouTube Live. So I am, of course, Mr. P from Flipping Physics. I have so many resources for you for AP Physics 1. I'm really glad to have you here. And, of course, the Ultimate Review Packet. So the Ultimate Review Packet and Ultimate Exam Slayer differentiate one another in that the Ultimate Exam Slayer is specifically for studying for the exam itself. It talks about the different kinds of questions, both multiple choice and free response questions, and has all of my free response question solutions, and has 2 practice exams in it. Whereas the Ultimate Review Packet is more centered on understanding the material itself and only has 1 practice exam in it. But both of them utilize our Ultimate Exam Slayer testing software, which is which mirrors the digital exam situation you're going to have when you take the actual AP exam. This is, of course, not endorsed nor by Blue Book or College Board. All right, so it looks like we're pretty close to there. So I think I'm just going to get started. So here we go. So what I need to do, just so you know, is I need to switch this. Oh, okay. So I'll go over here and make this full screen. Give me just a second. I got to do a couple little things here. And so this one goes here, and this one goes there, and we should be good. Right. Okay. So here we go. We're going to get started. It's a Kahoot by me, and you can see you can actually get started on the first question if you want to right now. All right, you can see choice A is the correct answer. Before I go through the solution, I will answer the question from Think with a Portal. Can you do one of these for Physics C kids? Yeah, I understand that you want me to. I understand that you guys always want me to do one for AP Physics C Mechanics, AP Physics C Electricity and Magnetism, and for AP Physics 2. I wish I had more time. That's really, it all comes down to time, and I just don't have the time to do it for all of them. So I'm really sorry about that, but that's just the reality. All right, so here we go. I want to go here. All right, so here we go. You can see we have our question over here, and then in question one. Okay, in question one, there are graphs, and I got to tell you, graphs, you have to understand graphs for AP Physics 1. So you're going to see a lot of graphs in my questions, and you have to understand them. So please get used to that. So another thing about this question is this type of setup here for the answer choices is a pretty typical table of answer choices you might see on the AP Physics exams. So just be aware of that. You might see tables just like this. All right, so here we go. So you need to be familiar with the 3 standard graphs of motion for an object launched vertically upward and caught at the same height. I'll just be honest with you, this is something you really need to understand. So we're going to walk our way through the 3 standard graphs of motion for an object launched vertically upward and caught at the same height. So we're going to build those 3 standard graphs for an object launched upward at 10 meters per second and caught at the same height. So here we go. We know the acceleration in free fall is negative 10 meters per second squared here on Earth. We're going to assume always that we're here on Earth, unless otherwise stated. And so that is going to be a horizontal line at negative 10 meters per second squared. So that graph looks like this. We also can look at we know the initial velocity is 10 meters per second and is changing at a constant rate of negative 10 meters per second squared. So class, what does the graph of velocity as a function of time look like for this situation? And anytime I put the word class on there, and I'm going to ask the question of you, my class, you are my students right now, so please answer the question in the chat. If given an initial velocity of 10 meters per second straight up here on planet Earth, what is the graph going to look like for velocity as a function of time? I'm going to wait for your comments to tell me. All right, so from Baby Lion, so far we have that it is a straight line. So I will agree with you. It is a straight line. So the velocity is decreasing, heading towards the negative direction. So first off, yes, it is a straight line. We have a bunch of people who say straight line. Straight line downwards is an interesting one. So I'm not sure what downwards mean. Do you mean straight down? We have our velocity is decreasing, heading towards the negative direction. So these are all good answers. So realize that this graph is going to be a straight line with a slope of negative 10 meters per second squared that starts at 10 meters per second. So again, we know the slope of a velocity versus time graph is acceleration. We know the acceleration is constant. So that means the velocity as a function of time graph is going to have a constant slope of negative 10 meters per second squared. And we know it starts at 10 meters per second. So that is what the graph of velocity as a function of time is going to look like. For position, we know instantaneous slope of a position versus time graph is velocity at that time. So this is going to be a concave down parabola. It looks like this. I've assumed it starts at the initial at 0 and ends at 0, but it could start anywhere because it didn't actually say in the problem. But that is what the general graph is going to look like. So if you're trying to answer this question, graph 1 has velocity on the vertical axis. The correct answer is A. So to answer your question, actually, I'll put it over here. Can we watch this later? So yes, absolutely. I'm going to just post this video. It's going to remain, the stream will be live, or will not be live, but you'll be able to watch it afterward. So yes, you can certainly watch it later. And anybody who missed it can watch it later as well. Okay, so now I will point out, if you're taking an AP exam and you've gotten this far, you haven't even addressed graph 2 and graph 3, but you know the answer has to be choice A. So my suggestion, if you're sure that you are correct that graph 1 has velocity on the vertical axis, then it has to be choice A. I would flag this in the software and then move on. And if you have time at the very end, come back and look at it again just to make sure. But honestly, if you know the answer, so the yeah, so okay. All right. So where was I? Okay. So we are, of course, going to go look at what graph 2 and graph 3 are, but you don't actually need that. You don't need that in order to solve this question right now. All right. So here we go. So graph 3 has position on the vertical axis. You could see that this matches. Graph 3 matches our position as a function of time graph. So that's graph 3. But the question is, how is it that graph 2 has speed on the vertical axis? Well, we know instantaneous speed is equal to the magnitude of instantaneous velocity. That word magnitude is very important there. Instantaneous speed is equal to the magnitude of instantaneous velocity. So from 1 to 2 seconds, so from 1 to 2 seconds, the speed graph is the positive value of velocity. So it's going to go and simply be the positive value of the velocity. So that makes it this one right here. So that is why speed is graph 2. And just so you know, in my video, AP Physics 1, Unit 1 Stumbling Blocks, Kinematics video, I go through a lot of, I talk more about this specifically if you have more questions about this. I'll just bring this up here. JG, I am glad you love my ed puzzles. They are, I'm glad I make them so that you guys, so your teachers can use them with you. And that's awesome that they are doing that. All right, so let's go back over here. I think we're done with question 1. Yeah, okay, we're done with question 1. So now let's see who's in the lead. So Blissful Eagle is in the lead. Congratulations, Blissful Eagle. Okay, so here we go. Oh, we got to go to question 2. So we are on question. Oh, we got to go to question 2, not question 3. Question 2. There we go. All right, here we go. So I want to bring up a comment here. Baby Lion, oh, I think I flipped my directions. So I do have in my solution, I talk about a way that helps you not flip your directions because I know a lot of us do that. So it's I'll talk about that in just a minute. But yes, that happens all the time with my students. All right, so here we go. Yes, we can see that choice B is the correct answer choice. And let's talk about what the okay. We got to go over here. Go to next. All right, so this is a relative motion question, but relative motion is vector addition. Literally, that's all it is. So you just need to understand that. Relative motion is vector addition. So we have a boat moves at 4 meters per second north relative to a river. So that is the velocity of the boat with respect to the river is 4 meters per second north. Again, a boat moves at 4 meters per second north relative to a river is the velocity of the boat with respect to the river, VBR, is equal to 4 meters per second north. We have a river which is moving 6 meters per second west relative to the earth. That is the velocity of the river with respect to the earth is 6 meters per second west. And the question is, the velocity of the boat relative to the earth is what we're solving for. So the velocity of the boat with respect to the earth equals question mark. So this is literally, as I said, vector addition. It is the velocity of the boat with respect to the earth is equal to the velocity of the boat with respect to the river plus the velocity of the river with respect to the earth. That is what we're solving for. So this is literally vector addition. I recommend you have to draw these things out. So we have the velocity of the boat with respect to the river, and then tip to tail vector addition, we put the velocity of the river with respect to the earth. We put the tail of that vector on the tip of the previous vector, and then the resultant vector starts at the beginning and goes to the end of both of those vectors. So notice that this question takes zero math to solve, right? The 7.2 meters per second, you don't need to solve for that. But so just be aware of that. There are going to be things like in a multiple choice question that you don't actually have to solve. But anyway, it's just important to realize. So all we have to determine is the direction of the velocity of the boat with respect to the earth. All we have to do is figure out this angle right here, theta. So what I suggest, which is going to help you not flip your directions, is to, whenever you do this and you're trying to figure out the direction, to draw out a little compass rose on the tail of the vector you're trying to figure out the direction of. So we have north, south, east, west. I've drawn on the tail of this vector, and we're trying to figure out what angle that is, theta. And so what you do then is you start from a cardinal direction and you go to your vector. So this literally starts at north and goes west. So it is west from north, or west of north. So the answer is, the correct answer is B. It is 56 degrees west of north. But if you want to see all the math to this, I did put that in the solutions in my quiz in the Ultimate Exam Slayer. I'm not going to walk through all that math today, but I think there's probably a question some of you might still have, and that question is, I drew the velocity of the boat with respect to the earth is equal to the velocity of the boat with respect to the river plus the velocity of the river with respect to the earth. That is what I drew. I could have drawn the velocity of the boat with respect to the earth equals the velocity of the river with respect to the earth plus the velocity of the boat with respect to the river. Right? That is equivalent, right? This results in the same resultant vector. The resultant is the same vector. It's the commutative property of vector addition, right? So this is the same vector, but this theta 2, is not the same as theta 1. But again, we can draw our north, south, east, west from here. And now from this cardinal direction, west, we go north. So it is north from west, or north of west. So theta 2 is actually 34 degrees north of west. So this direction of 56 degrees west of north and 34 degrees north of west are the same direction. But how did I know it was going to be 56 degrees and not 34 degrees? Well, I know that because theta has to be greater than 45 degrees. So the theta we're using, so theta, it has to be theta and not theta 2, because the velocity of the boat with respect to the earth is greater than the velocity of the boat with respect to the river. Therefore, this angle has to be greater than 45 degrees. So that is how I solved that problem. Okay, moving on to question 3. Actually, let's see how we're doing over here. We have, oh, Funky Narwhal, followed by Funky Possum. Nice. Love it. Okay, a lot of funky. All right, so let's go to the next question, going from question 2 to question 3. Perfect, and we'll go next.
All right, the correct answer is B. Before we talk about that, I just want to go through a couple of comments here. Forestburg, you are absolutely welcome. Thanks. Thanks so much. Baby Lion, what should you do if it is 45 degrees? So if it's 45 degrees, that's what northwest means. So with no 55 degrees north of west or anything like that, if you just say northwest, you mean bifurcating north and west. So it is 45 degrees. So northwest, southwest, northeast, and northwest all specifically mean at a 45-degree angle. So if it is 45 degrees, it would just say 45 degrees north, or I'm sorry, it would just say northwest, just so you know. All right, so let's go back here. We're now looking at our solution to question 3. We got to get to question 3 here. Boom, boom. All right, so question 3. Again, is a table of choices like you might see or will see on the exam. So from experience doing problems, you should learn that. And this is true on a lot of AP exams, and AP Physics is no different, that they do depend on, or it's very helpful if you have gotten a lot of experience doing problems and doing labs and understanding things. So realize you're going to gain better understanding of all sorts of things as you go through and do problems, including today as we go through these things. So when a ball is thrown straight upward and returns back to the same height, it has the same magnitude velocity with which it was thrown upward, only now the ball is moving downward. So again, if a ball is thrown straight upward and returns back to the same height, it will have the same magnitude velocity at that height at which it was thrown, only now it is moving downward. So class, if it was thrown upward at 5 meters per second, when it returns to the same height, what will its velocity be? Again, class, this is a question for you. Leave a comment. I'm not asking for the answer to question 3. I'm asking the answer to the question, what is the velocity of the ball when it returns back to its same height if it was thrown upward at 5 meters per second? Love it. We've got 2 correct answers. Actually, we're gonna go through a couple of these. I like this. Okay, so first off, we've got this one. Absolutely, -5 meters per second. -5 meters per second with a question mark. Never put a question mark on an answer. Just stick to your guns. Come on, just stick to it. It's -5 meters per second. I love this answer as well. These are both correct, -5 meters per second or 5 meters per second down. Realize when you use it in a problem, you want to use -5 meters per second, but you can also describe that as 5 meters per second down. Beautiful. All right. Now, 5 meters per second down, as we just talked about. So again, instantaneous speed equals the magnitude of instantaneous velocity. Again, the word magnitude is very important here. So it is true that the speed initial equals the speed final. So that means that
And we also know that velocity initial does not equal velocity final. Up is not the same as down. So the correct answer is B. Beautiful. A little bit more. Now, when a ball is strained through a throat, this whole thing we just talked about, I want to walk through just a quick proof of how this works. We're going to prove it. And because proving things is something you might have to do on the AP exam. In fact, the might word not might have, shouldn't even be there. You're going to have to prove stuff on the AP exam. So you need to get used to it. So we have our knowns. The initial velocity in the y direction is a known variable. The acceleration in the y direction equals negative of the gravitational field strength that equals the negative of the acceleration due to gravity, known variable. The displacement in the y direction equals 0 because it comes back to the same height that it started at. It doesn't mean it didn't go up or down. It simply means that it starts and ends at that same height. So the displacement in the y direction is equal to 0. So the velocity final in the y direction equals question mark. That's what we're trying to see what it is. So we can use one of our UAM equations. The velocity final in the y direction squared equals the velocity initial in the y direction squared plus 2 times the acceleration in the y direction times displacement in the y direction. Again, this is one of our uniformly accelerated motion equations, often called the kinematics equations. You can use these when the acceleration equals a number when the acceleration is constant. And you can see that is true here because the acceleration equals a number. So plugging in our numbers, 2 and negative g and 0, this whole term cancels out, and it's just velocity final in the y direction squared equals velocity initial in the y direction squared. And we can take the square root of both sides. We get the final velocity in the y direction equals the square root of the initial velocity in the y direction squared. So the square root of that is plus or minus the initial velocity in the y direction. Therefore, we know the velocity in the final in the y direction equals the negative of the initial velocity in the y direction. We know it is negative because we know it has to be coming down. So again, we have just proven that the magnitude is the same when it returns to the same height, but it is now has a different direction, is now moving down. Therefore, the velocity final in the y direction is not equal to the velocity initial in the y direction. Beautiful. All right, let's move on to, okay, let me go here for a second. Let me, Juliana Baum, let's see if I can answer that. So are we assuming constant acceleration for number 3? I'm assuming you mean question number 3 that we're going through right now. So whenever an object is near the surface of a planet, you can assume the acceleration is constant because the acceleration is the acceleration due to gravity, little g, or well, say has a magnitude of little g, it's equal to the negative of the acceleration due to gravity because it is the direction is down. So yes, anytime something is in free fall, you can use those uniformly accelerated motion equations. You know the acceleration is constant because the acceleration has a magnitude equal to the gravitational field strength. Beautiful. All right, let's move on to question. Oh, I'm sorry. I apologize. We have to see how everybody's doing. And Funky Narwhal in the lead. Well done, Funky Narwhal. Funky Narwhal. All right, so here we go. The next question is question 4. I got to be careful when I do this. Question 4, beautiful. And we're on the next question. Oh, I got to do this because there's a visual you cannot see. Boom, boom, boom. There we go. Actually, I'm going to pull this all the way over so you can see it a little bit better. All right, the correct answer is D. Neither of those two statements is correct. Let's talk about why that is. Okay, moving on to the next question. So, question 4. Actually, let's do this. So, just these dots to represent the location of an object are very old school. I mean, it's so old. I didn't even do this when I was in high school. It is slash was called ticker tape. Basically, it was a long roll of skinny tape that you would attach to an object, and as the object went, there was a little thing that would make a dot at even time intervals on that tape. So it's called ticker tape, and you could measure the location of the object basically using that. You don't actually have to understand that for this, but realize this idea of showing the location of the center of mass at even time intervals is probably going to come up because it's a pretty standard way of showing motion in physics questions. Okay, so both objects have a displacement with a magnitude of 20 meters. You can see that because both objects go through 20 meters here from here to here. Great. Oh, we just used I'm sorry. You just used those in class today. That's awesome. I love old school stuff. Anyway, so answer choice A is incorrect. Object 2 does not have a larger magnitude displacement than object 1. Okay. Realize both objects have the same number of dots. That means the change in time for both objects is the same. Average velocity equals displacement over change in time. So both objects have the same magnitude average velocity, and I believe we've gotten to. So answer choice B is incorrect. So neither A nor B is correct. So the correct answer is answer choice D. Beautiful. Question 5. But before we do that, of course, let's do this so we can see a little bit better. We have Funky Narwhal, Vivid Swan. Okay, Gary Leopard. Good job for your streak there. You're on fire. All right. We need to go from here to go to the next question, and next. Good luck. All right. Choice C is the correct answer. All right, let's take a look at this solution. So again, we're switching it to choice 5. I'm going to bring up the visual real quick. Okay. In question 5, to help us understand the motion of these objects, we're going to graph the position as a function of time for both objects. I'm going to do that on the next slide, so it's not a tiny graph. Here we go. So we have object 1 goes through equal changes in position over change in time. So that's going to be a straight line that goes from 0, 0 to 20, and there's a position and the full time here. So you can see that matches each of these. And then object 2, which I put in red, has a smaller distance traveled during the first time, and then the distance traveled for each one increases, and so that's what those dots are going to look like. I find it easier to see if it looks like this rather than this, so we're going to use the lines, we're going to connect the dots to just visualize what's going on, because we're assuming that that's what this is going to look like, because we can connect the dots in this particular case to see what the overall trends for the objects are. Okay, so now we're trying to answer these questions. Here we go. Oh, actually, notice there are no times on the horizontal time axis. They didn't give us any times in this problem. It's gonna be okay. You don't actually have to know the time. All you need to know is that they are even time intervals. Great. Okay, so question 5. Here we go. Choice A is about acceleration. So let's yes, the Kahoot number is in there, and Kira Bonk will give it to you in a minute. Okay, so choice A is about acceleration. So let's talk about the accelerations of these. Object 1 has a constant slope. Therefore, this is a constant velocity. Therefore, there is 0 acceleration. Object 2 has an increasing slope. Therefore, an increasing velocity. Therefore, it is a positive acceleration. Therefore, choice A is incorrect. The magnitude of the average acceleration for object 1 is not greater than the magnitude of the acceleration of object 2. Great. Choice B is about instantaneous velocities at 20 meters. So right there, what are the instantaneous velocities? So the slopes of the tangent lines to the curves at 20 meters are different. So these two instantaneous slopes, for object 1, it's going to continue this line. For object 2, it is some sort of line that goes like this. And so those are two different slopes. So the objects have two different instantaneous velocities at 20 meters. Therefore, choice B is incorrect. Choice C is about instantaneous velocities at some location before 20 meters. So somewhere in here, are the magnitudes of those two instantaneous velocities the same? So the slopes of the tangent line occur to be roughly the same at the midway point. So right here, you can see the slope of the tangent line for object 2 roughly matches the slope of the line for object 1. So you can see at that point that the two objects have the same magnitude instantaneous velocity at some point before 20 meters, because that is that point. So choice C is the correct answer. Now, choice D is also about acceleration. We already determined that object 1 has 0 acceleration. Object 1 is not slowing down. Therefore, choice D is incorrect. Beautiful. Let's move on to question 6. Let's see how everybody's doing. Funky Narwhal? Nice. Funky Narwhal. Vivid Swan. Beautiful. All right, here we go. Next question is going from 5 to question 6. Let's move. Well, let's start up here. Boom, boom, boom. Let's get the question started. And then, actually, we can do this. There. Whew. Oh, I love it. I love it. Okay, so real quick, we're just gonna put this up there. I had to drop some pencils to see how it would look. Thank you. Made me laugh, chuckle. Beautiful. All right. So the correct answer is D. This will be fun. Let's walk our way through why this is the answer. All right. Here we go. Question 6. The train is moving to the right on the screen. To a person on the train, stationary objects not on the train will appear to move in what direction, class? Again, this is a question for you. Answer in the comments. To a person on the train, stationary objects not on the train will appear to move in what direction? Correct. It's important. Left is the actually here. Whoop, move to the left on the screen. So it is important to recognize that to a person on the train, stationary objects not on the train will appear to move to the left on the screen. Perfect. Now, the ball is not stationary. It is also moving downward. In fact, it is accelerating downward because so the correct answer is either C or D. So the ball is accelerating downward. So it will have a slower speed at first, and that speed will increase as it moves lower. So to a person on the train, it looks like the ball was thrown to the left on the screen with a constant horizontal velocity. So the ball appears to follow will not be a straight line. I'm going to read that whole sentence. The path the ball appears to follow will not be a straight line. It will be a parabolic curve. Okay, good. The sentence does make sense. I thought it didn't. Okay, so it's going to look like it follows a parabolic curve, which is exactly what that looks like for D. The correct answer is D. Beautiful. All right, question 7. You can see, get excited. That's what it's going to look like. All right, so let's see. Funky Narwhal. Nice. Ooh, vivid something or other fell off, but Funky Narwhal. All right, we'll have to see if Funky Narwhal is going to be dethroned. Here we go. Moving from question 6 to question 7. I'm going to click next. Then I will make it so we can see what the stimulus looks like. All right, here we go. Choice B is the correct answer. Let's see why that is. We move to question 7. We've got that there, so we don't need to do that. Okay, so question 7. So the velocity in the x direction of an object in projectile motion is constant. So for right triangles, we know the horizontal and vertical sides of the triangles are equal at 45 degrees. So that's what we're looking for. At which point of the ball's path will the magnitudes of the vertical and horizontal components be the same? So that's when it's going to be when it's 45 degrees. So that horizontal component and vertical component are going to be the same when this angle right here is 45 degrees. So what I've drawn out here are all of the vectors. You can see the velocity in the x direction for each one is the same, and the velocity in the y direction decreases as it moves up, is 0 at the very top, and increases all the way until we get down to there. So the ball is launched at 70 degrees. So at point A is shortly after the launch. So theta A is going to be a little bit less than 70 degrees. So choice A is not the answer. Choice D is nearly at the same height as launch. Therefore, theta D, excuse me, that should be a D. Choice D is roughly 70 degrees. So choice D is not the answer. And so at C, the angle is actually 0 degrees because there's no y component. So then you could see for choice B that the angle is roughly 45 degrees. So choice B is the correct answer. All right. Let's see if Funky Narwhal is still in the lead. Ba, 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 ba. Oh, Blissful Eagle takes over. That's rough. All right, here we go. Moving on to the next question, from question 7 to question 8. Next. All right, so the correct answer is choice D. Interesting. That's the least number of people got that right. All right, good. I'm glad I asked this question then. All right, so, or maybe I got it wrong. We'll find out. All right, so the ceiling is 5 meters above. So here we go. This is a standard projectile motion problem. We have our knowns. The initial launch angle is 55 degrees. The acceleration is negative 10 meters per second squared. The displacement of the y direction is 5 meters, and the velocity final is equal to 0. We're trying to figure out what that initial velocity is. Okay, so realize what I've done here is I've set the maximum height to be 5 meters, with such that it'll be at the very top of its path. We're just figuring out what the maximum speed will be to get to a displacement of 5 meters. So again, this is, we can use we can use the uniformly acceleration motion equations because the acceleration is a constant number. Velocity final in the y direction squared equals velocity initial in the y direction squared plus 2 times the acceleration in the y direction times the displacement in the y direction. The final velocity in the y direction is 0. We know the acceleration negative 10. We can substitute in 5. When we do this, we get that the initial velocity equals the square root of 10, or square root of 100, so positive or negative 10. So positive 10 meters per second. We know it's positive because it's moving up. So we have figured out the initial velocity in the y direction. But we need to figure out the initial velocity, not just the initial velocity in the y direction. So the initial velocity in the y direction is this part, but there is also an initial velocity in the x direction. So we know sine theta equals opposite over hypotenuse. So the sine of theta initial equals the velocity initial in the y direction over velocity initial. So therefore, we can solve for that velocity initial equals velocity initial y direction divided by the sine of theta initial, or 10 divided by the sine of 55 degrees, which is 12.208 meters per second. So it could be anything less than 12.208 meters per second, and it will not get up to 5 meters. All of these are less than that. So the correct answer is 12. Of these answer choices, the largest one that will not hit the ceiling is 12 meters per second. Correct answer is D. Question 9. Actually, let's see where we are now. Ooh, all right, fun stuff. All right, moving on to question 9. Perfect. All right, awesome. Choice D. Much better than the last one. Okay, so here we go. Question 9. The magnitude displacement of runner P is 100 meters. To determine the magnitude displacement of runner Q, we need to use the Pythagorean theorem, a squared plus b squared equals c squared, or q in the x direction squared plus q in the y direction squared equals q squared. Therefore, q is the magnitude of q is equal to the square root of q in the x direction squared plus q in the y direction squared, or 60 squared plus 80 squared, the square root of that, which is 100 meters. Both runners have the same magnitude displacement. The correct answer is C. I'm just going to point out that common triangles like this, or multiples of common triangles like this 3, 4, 5 triangle, they used to come up pretty often on the AP Physics exams. I don't know if that's going to be true in the future, but it's useful to remember the 3, 4, 5 triangle, or it might be. That's all I'll say about that, I guess. Yeah. All right, question 10. Oh, actually, hold on. Ooh, let's see. Okay. Bliss. Ooh, it's very close between Visible Eagle and Astonishing Bear. It's got to be close. Here we go. Question 10. Oh, I got to get the stimulus in there too. Do, do, do. All right. Choice A. Well done, everybody. Couple quick things. Let's do this. Let me just talk about this real quick. Um, this is about feeling bad and struggling through this class. I'm going to be completely honest with you. It can be hard for students. For a lot of my students, this was one of the first classes where they ever actually had to study, and they had to learn how to study for this class. And it involves a way of thinking that is different than what you've done before. This involves math and science together. So it really is a different way of thinking, and it just takes time. Got to be the more practice you can do, the better. Really, that's really it. I mean, and you're not alone. It is not an easy course. Just be aware of that. Another quick thing, realize this is the last question we're going to do today, but this is only question 10 out of 26. If you do get my Ultimate Exam Slayer, you do get to get the access to the other 16 of those. And also be aware, like, I literally set it up so that, like, I have my solutions in here. When you look at this, like, it shows the whole thing. So, right, I actually walk all the way through the solutions. It's not just the answer, it's the entire solution. So just be aware that you get that. All right, here we go. Question 10. Let's talk through this question. Let's do, I don't know how I look at it yet. We'll see. So the slope of a position versus time graph is velocity. Let me do this. So the slope of a position versus time graph is velocity. The initial slope of the position versus time graph needs to be a negative number, right? The only choice, answer choice with which this criterion is answer choice A. This value right here needs to be the initial slope. So you could see here that the initial slope of this one is negative, this one's positive, this one's positive, and this one's 0. So again, this is going to happen. You don't have to get very far into this to get the right answer. I, of course, am going to walk my way all the way through this, but here we go. Answer choice A is the correct answer. So let's just make sure you understand all this, because helping you understand is why I'm doing this. So question 10, at the midway point in time on the velocity versus time graph, the velocity is 0. So right here, the velocity is 0. That means the slope of the position versus time graph at the midway point in time needs to be 0. That only happens in answer choices A and C. So the slope here is 0. The slope here is 0. I guess actually it does happen in this one. Sure. But this one, the slope is not equal to 0. The final slope of the position versus time graph needs to be a positive number. You can see up here, it is this value is a positive number, so the slope needs to be positive. This has a positive value. This does not. This is negative. This is 0. And this is a positive value. So only answer choices A and B have a positive slope. So choice B is so be aware of that. So answer choice A is the correct answer. Notice answer choice B is the same as the velocity versus time graph. These two graphs are the same. And a position versus time graph and a velocity versus time graph cannot be the same for an object. I'll say that again. A position versus time graph and a velocity versus time graph cannot be the same for an object. I'm going to wait till someone corrects that statement because it's not actually correct as written. Class. A position versus time graph and a velocity versus time graph cannot be the same for an object. I'll give you a hint. You only need to add 2 words at the end of the sentence. Alternatively, you could change 1 word and add 1 word. Interesting. Sydney, I like that question. I like that question. We'll talk about that in a second. Okay, so here we go. A position versus time graph and a velocity versus time graph cannot be the same for an object in motion. So if the object doesn't change position, a stationary object at the origin will have identically shaped position versus time graph, velocity versus time graph, and acceleration versus time graphs. So it will have a position versus time graph, which is a flat line at 0. It's not moving. It has 0 velocity, so it will have a velocity of 0 the whole time, and it has 0 acceleration. And Sydney, that is a valid point. If the position is e to the x, you're correct. The slope of that is the same. I totally forgot about that one. That's a lovely. Although, is it the same? I'll have to think about that one. I need to think about. I think that's right. Unfortunately, I can't work all the way through it right now, but that's great. So I do want to answer a question here. Hold up. So this question right here, do you have your own order of operations for solving questions the fastest? I really don't. I mean, Kira, Miss Bonk talked about something right here. Yes, listing the give. Actually, we'll bring that up. This is a good strategy. List the givens, identify what you're solving for, draw a picture. Drawing a picture can be helpful so often. And then, yes, identify an equation that what you're solving for. Sure, that's a valid strategy. Especially right here in Unit 1, things do get different as far as when we get farther into things. But yeah, this is all useful stuff. Truth is that in all of my questions, I solve things in a way that I think is the best way to solve them in the most efficient manner. So really, I model it all very well. But Miss Bonk, those are some really good suggestions. All right. Let's go over here. All right. So I do think that is enough for today. We are done. So my plan is for this video to remain live on YouTube so that you can watch it later. Your friends can watch it, whoever needs to do this. Again, I said there's multiple choices posted in my Ultimate Exam Slayer. There are 60 more questions in the Ultimate Exam Slayer. Unit 2 will be on Tuesday, October 21st at 7 p.m. Eastern Time. I'm hoping you can be here. Yes, Cindy, I totally agree. on the fly, I'm not sure I'm going to fully agree, but yes, I'm 99% sure you're correct. Not one that I had thought of, which is wonderful. I love learning. All right. Thank you very much for learning with me today. I enjoy learning with you. Oh, I love I love these comments. You are very welcome. Best of luck on your test on Thursday. That's beautiful. So glad I can help. And yeah, Sydney, I totally agree. It's beautiful. Valid point. Did not think of it. That's the way it is. It's the way life is. Again, I love learning. Beautiful. Let's do this. All right. So I'm checking out. Y'all have a beautiful day.
Physics.